Good morning to all of you. Today we are going to see this is one very interesting subject. This is called buoyancy and flotation. Yesterday we have already understood the basic part of this buoyancy and flotation, and I already told you how to find out the magnitude of the buoyancy force and what should be its location and what should be its direction. So today we are going to see in detail regarding this buoyancy and flotation. So suppose this is a container. Okay, suppose this is a container. So in which there is some liquid is there. And suppose a body you have submerged one cylindrical body. So this is one cylindrical. This is one cylindrical body. Okay, cylindrical body. So if you want to find out this, what should be this is center of gravity. Okay, and the center of buoyancy will be this one because it is already submerged. Okay, so there is a thrust, there is a force which is exerted by this water. There is a liquid is there, the water is there. So this upward of thrust which is exerted by the fluid to the submerged body, that is called upthrust, or that is called force of buoyancy. Okay, so already you have told how to find out this force of buoyancy will be equal to the weight of water displaced. Weight of water displaced by this body, that is nothing but density of this water into G into how much volume has been submerged by this fluid. This is called force of buoyancy. Okay, so this volume of submerged means means I can say how much part has been submerged or how much water has been displaced. How much water has been displaced. I can write this is how much volume of the, in simple language, volume of the solid surface of the solid has been submerged. That will be equal to the volume of water will be displaced. So this is, I am talking about this magnitude. This is the magnitude. After that, we have to locate this point of location. Point of location. Where actually it will act. So it will act. This force will act at the centroid of the volume of liquid displaced. It will act the centroid of the volume of the liquid displaced. That centroid is nothing but is called as center of buoyancy. It is called center of buoyancy. Okay, so it will act at the centroid of the volume of the liquid displaced. That is called, this force will act at the center of buoyancy. Means you can write also in the centroid of the submerged surface. Okay, centroid of the submerged surface is also called as center of buoyancy. And always, what is the direction of this force? It's always act in upward. It's always act in upward direction. Okay, against this motion of the body, upward. This is the point. So is the weight. This is the point. So this is the point. So is the weight of this solid surface of this body will act. And this is the point through which this is called point of. This is this same point. Set. Okay. This is called center of buoyancy. Okay, so this buoyancy force will be act. So already we have known. So if you talk about what is the horizon, if you draw the free body diagram, of this one, so this is my cylindrical body. So this horizontal component, So this is F hydrostatic force 1. This is hydrostatic force in second part. So if you find the net, force, so in horizontal direction, that will be equal to 0. So there is only one component of the hydrostatic force will act in upward direction. That is called this vertical hydrostatic force. Okay. So So now, suppose I will talk about some cases. This is one. Suppose this is a multi-layer fluid. Case of a multi-layer fluid. Multi-layer fluid. Case of a multi-layer fluid, what will happen? Suppose this is my container in which some layer of liquid is there. Okay. Suppose this side will be H1. This is H2. This is H3. And this about this at this layer, at the density of the liquid ρ1. This is ρ2. This is ρ. Suppose this is oil, and this is water, and this is a mercury. Okay. If you suppose suppose one body you have submerged, which is touching all this surface, all this layer. So this is my body, which is actually touching all this layer. And suppose this the volume of this the solid surface is Vs. So if you want to find out in case of multi-layer what should be the buoyancy force, so this is nothing but density of the first fluid layer 1 into G into how much has been submerged in first layer. This is the submerged part in first layer. Okay, first layer plus density into 2 into G, how much has been submerged in second layer. The second layer has been submerged. Or you can say how much fluid has been displaced by the solid surface. Or we can sing the simple language, we can say how much solid surface has been submerged in second layer. This is the part of the solid surface second layer. This is the part. So how much volume is submerged in second layer. So if you similarly density 3 into G, this is the third part has been submerged. Okay, so what is V1? This is V1 is the volume of solid surface, submerged in oil. Similarly, if you write down the what is V2, if you write down V2, this is volume of solid surface submerged in water. Similarly, if you write down this V3, how much volume of solid surface submerged in mercury. This is the entire thing. So this is the way in which we can calculate the multi-layer fluid. So I will discuss now some case. Okay, some case. So suppose this is first case. This is case 1. So in case 1, this is called this case 1. I am talking about this flotation condition, floating condition. So this is floating condition. This is floating condition. So this is my case 1. Suppose in floating condition, this is a container. In which the floating condition means some part of the body is under the water, under the liquid, and some part of the body is above the liquid. Okay, that is called floating. So this is the floating condition. Some part of the body is under the liquid, and some part of the body is above the liquid. This is floating condition. So, if you talk about this is the volume of the submergence, and so this is the volume of the submerged solid surface. So in this case, the volume of the submerged, this part is submerged. This is definitely less than, suppose the entire total volume of the solid is Vs. This is Vs. Vs is what? This is total volume of the solid surface. Okay, the total volume of the surface. What is this V? This is the volume of the this solid surface which is submerged which is submerged in liquid. Okay, so if you want to draw the free body diagram, of this one, in buoyancy force, you always have to draw the free body diagram. This is my solid surface. Okay, and through this center of gravity, what will happen? The weight is acting. Weight of the solid surface is center of gravity, and the center of buoyancy will be this one. This is centered of the volume, centered of the submerged surface. So through this, what will happen? The buoyancy force will act. So if you do the summation of f of y will be 0. You take this one by positive x, and this is my positive y axis. So if you do this one, so this will come out to be force of buoyancy minus ws will be equal to 0. So if you do this one, force of buoyancy will be equal to how much? Ws. So from here, this force of buoyancy I can write down. Already I derived this magnitude of the density of the liquid into g into how much volume has been submerged. This is the volume has been submerged. Okay, so will be equal to density. Where I can write density of the solid surface into g. This is volume of the solid surface into g, mass into g. So if you this g gone, if you write down, this is density of this liquid divided by density of this solid surface, solid body, will be equal to volume of the solid body divided by how much volume has been submerged. This is the equation. So from this already we have known. Already you see from this one. Already we have known this one. This is volume of the solid surface is more than volume of the submerged. Means this volume of the solid surface is greater than how much volume has been submerged. What is signifying? It's signifying that density of this liquid is more than density of the solid body. So if this condition will prevail, density of this liquid will more than density of the solid, then that is a floating condition. Okay. You see, if the you take example of the plastic, if density is less than water, you drop the plastic ball into this water, that will not submerge, that will float on this water. So similarly, if you take a metallic body, metallic body have density around this 7,000 to 7,800, which is definitely more than the density of the water. You put that one, it will not float, it will submerge, it will sink, it will go and completely enter this water. But this mercury, to take the example of the mercury's density is very high. Almost all body which will be put under this mercury liquid, it will not submerge, it will float. So mercury is an example. Its density is at the density of the mercury is very high. So if you can put any solid body, that will float in mercury. So second case I will talk about suspended condition. This is second case. Second case is suspended. I will give this note to you also. So don't worry for this one. Suspended condition. So just subscribe my channel and share my channel so that I can get some motivation to do some more video for you. Suspended means this is the case. So this is the container with the liquid or water is there. This is suspended. It is submerged. It is submerged, but it is not gone to the bottom part. It is not touched the bed. So it is suspended. It is in between this liquid. It has not sink to enter this bottom part. It has not touched to the bottom part. So if you want to find out, so what should be this volume of submerged? This is completely submerged. This part is completely submerged. It's nothing but equal to the volume of the solid surface. This is volume of the solid surface. So if you draw the free body diagram of this one, so see, this is the center of gravity. This is under this weight of this one, and this is center of buoyancy, center of gravity. So with the this buoyancy force will act. So similarly, if you do, this is net force in y direction will be equal to 0. This is my positive x and this is my positive y. So similarly, if you do, this is force of buoyancy minus weight of the solid body will be equal to 0. So force of buoyancy will be equal to weight of the solid body. So force of buoyancy already know, the density of the liquid into v into how much it is called entire submerged. So this is density of the solid body into v into this volume of the surface. So if you do, this is same. Already you know this one same. So this is cancel. Cg cancel. So here this is density of the liquid will be equal to density of the solid body. So if this condition will prevail, that is called suspended condition. Suspended condition means in suspended condition, the density of the body which we are already were putting in this liquid, the density will be equivalent to density of the liquid. That is the condition of the suspended condition. So if you want to discuss hard case, this is called case 3. This is called sink condition. This is sink. This is called sink condition. This is completely in submerged. So this is sink condition. This is my container in which the water is there. So this is completely. This is already close to this ground surface. Solid will already close to the ground surface. So in this case, same case. This is what is the volume of submerged. If you want to do what is the volume entire submerged, the body is completely submerged in water. So which is equal to the volume of the solid surface or solid body. Okay. So now to draw the free body diagram. So this is my solid body. Under this one center of gravity which is G. So weight of the solid body will get. This is center of buoyancy. So pro is what will happen. The buoyancy force will get. And see at as this body is contact with this bed. This is one my bed. No? So there is a reaction force. There is a reaction force will given by this surface to this body. So there is a reaction force. There is a reaction force which is given by this surface to this body. So if you do, this is my positive x and this is my positive y coordinate. If you do this, summation of f of y will be equal to 0. So this if you want to write down, so f of b plus this r minus ws will be equal to 0. So if you see, if you want to find out the buoyancy force, this is weight of the solid body minus r. Okay, minus r. From this, the buoyancy force magnitude is less than the weight of the solid surface. Okay, buoyancy force, I can write down this one. Weight of the solid body, which is more than this buoyancy force. Okay, weight of the buoyancy force means what? It means if you want to write down this one, this is density of the solid. This is G into volume of the solid greater than density of the liquid into G into it is completely submerged. So this G, this Bs already gone. So the same density of the solid body is greater than density of the liquid. When this condition will prevail, that is called sinking. This body will be sink, completely sink to the bottom. Okay. Now I will solve some numericals for you, so that you will get some brief idea. So first numerical is a large vessel. Okay, already the shown in figure contains oil and water. Okay, so this is the case in which this container is there. So in a container is there. Okay, in a container is there, in which there is a oil is there and water is there. And this is your oil and this is your water. So what will happen is saying that 45% of this body, 45% of the volume of the body is under this oil and 55% of the body is under water. So suppose there is a body in which this volume which under this oil is 45% and under the water is 55%. So it is asking what should be this density of this solid body. what should be the density of the solid body. If the density of the oil is given you, the density of the oil is given 700 kg per meter cube, and density of the water already you know, this is 1000 kg per meter cube. So G also is given 10 meter per second square. So it is asking about this one. So this is a case of suspended condition. This is suspended. This is completely submerged, or this is not touching to the bed part. So this is a case of suspended condition. Okay. This is a case of suspended condition. So now if you draw the free body diagram of this body. So this is my suppose this is my body, and suppose this is my center of gravity. So the center of gravity total upon my this weight of the solid body will act. This is my center of buoyancy will be suppose this here. So here will happen my force of buoyancy will act. So if you assume this one my positive x, and similarly this one my positive y. So now if you do net force y will be 0. So same f of b will be equal minus ws will be equal to 0. So this is f of b will be equal to w into s. So f of b, what is the force of buoyancy? This is a multi-layer liquid. I already told you. So first is density of the oil into how much volume has been submerged in oil. This is the part which is submerged in oil. Some part of them, this is 45% underwater, and this is G. Okay, plus density of the water into this is the part which is under this water. And this is the part which under this is 55% has been submerged. So this is the part into G, which will be equal to how much? Which is equal to density of the solid surface into volume of the solid body into G. So G it is completely gone. So if I have told you the volume of the solid surface is Vs. So the volume, how much volume has been submerged in oil? That is 0.45 of Vs. So how much volume has been submerged in water? That is 0.55 of Vs. So directly I can put here the density of the oil is given to you. This is 700. Okay, into this is G is not required. The volume is 0.45 Vs plus this is 1000. Okay, 1000 into 0.55 Vs, which will be equal to rho s into Vs. So this Vs. From here you can find out this density of the solid surface or solid body. So density of the solid body will find to you this will come out to be 1865. This is kg per. Okay. So next problem is, so a cylindrical body of cross-sectional area A, height h. Okay, then this is the case. So this is a cylinder container. This is one container which this is my container in which water is there. Okay, and one body has been actually cubical body is there, and it is attached to this bed part. This body is attached to this bed part through the string. This is one string. So this is my string. This is this cross-sectional area of this form is A. Okay, cross-sectional area is 1S, and this is the submerged. This is the submerged part. This is small h, and this is the total height h, given US capital H. This is capital H. This one is capital H, height of this body, and density of this one is given as density of this fluid is given as 0. So it is asking what is the tension developed in the string. Okay, so this is the condition of the floating condition. This is a floating condition. Okay, this is one floating condition. So if you want to draw the free body diagram, In buoyancy problem, you have to draw the free body diagram of this body. Then only you can solve the problem. So this is my body, solid body. Okay, the weight is acting downward. This is my weight of this solid body, and this buoyancy force will act upward in direction. So similarly, same you have to take a positive x, positive y coordinate. So similarly, f of y will be equal to 0. That force in y direction is 0. So see, a string is acting, so there will be tension. Tension means what? Away from the string, and compression is toward this. This is tension, this is compression. So there is a tensile force also will act. So this is the string, this is tensile. So if you want to write down, this is P, okay, plus WS, P plus WS will be equal to buoyancy force. So this E will be equal to buoyancy force magnitude minus W. So what is buoyancy force magnitude? Density of this liquid, okay, into G into how much volume has been submerged. How much volume has been submerged? This is the part has been submerged. And density of this solid surface into G into this volume of the solid body. Okay. So this is density is given Q as rho, density of the liquid, and G, and this volume of the submerged. This part has been submerged. This is the part has been submerged. This is the part has been submerged under this water. Okay. What should be this volume? Cross-section area is given. So this cross-section area into small h minus density of the body G, and volume of the solid surface is given A into capital H. Okay. So if you do this one, this will come out to be density into small h minus density of the solid body into capital H into G into H. So this is the tensile force developed in the string. Okay, this is one very good numerical. Now another problem is there. This is also a very good problem. This is a get problem. So a cube of 100 mm side and density is given 800 kg per meter cube is kept at the base of container, and then the liquid of density 1000 kg per meter cube is poured into the container. The minimum height to which the liquid needs to be poured into the container for the cube just to lift up. And this is the case. So this is my container. Okay, this is the gate 2019. So this is the gate. This is the gate 2019. So this is my gate. So initially what will happen? The cube is there. The cube is there. Okay, and the height of this, the size of this cube is 100 mm. This is 100 mm. So what will you have to pour a liquid? Pour a liquid of density how much? 1000 kg per meter. This is directly this is therefore water. Density is given 1000 kg per meter cube. So what will happen when this water will be poured? Then the liquid will give rise to a buoyancy force to this cube. Okay. Suppose, for example, I am saying the water has been poured to this side. This is the height after which the water has been poured. Suppose this height is small h. So we have to estimate this height at which the cube is just starting to lift up. Okay, just starting to lift. So initially when water is not there, there is only the self weight of this cube is acting. But when you add the water to this one, so what will happen? When you add the water to this one, so what will happen? The buoyancy force will acting on this body. So this is a case of what? First case. It is floating condition. They just start to move. So if you draw the free body diagram, very easy. It is asking to estimate this one. This what should the height of this water when just start to move upward. So if you draw the free body diagram, so this is my cubical body, and this weight will act downward. This is weight, and this is here a buoyancy force will act. Okay. So so this is V. What is V? This is the volume of the solid in liquid. So this is I can reference the volume of water will be displaced, and how much volume of solid inside the liquid, that much of water will be displaced. And it is asking at the I can say uh, equilibrium condition, means at the verge of moving. Okay, so at the verge of moving I can write then the force of buoyancy just greater than equal to the self weight of this body, or at equilibrium this force of buoyancy will be equal to this weight of the solid body. So this is I can write around this is I'm directly writing the density of the liquid water is 1000 into G, and this is how much is in summer. Suppose this is in summer will be equal to this density of this solid body into this is G into this volume of the solid body. Okay, and I can write down this one as 1000 into G, and this volume of sum of this cross sectional area is A. Okay, and this height is suppose small h. I already told this small h. This is the volume sum, and this density is given you 800. This density is given, density of the solid body is 800. This is G, and this volume of the solid body, that is you can find out this cross sectional area into this 100, and the unit of conversion is not required. So the G A G is 1. So if you want to find out this H, this is coming out to be 80. So this is K 2019. Okay, so I already discussed the buoyancy force, and I have solved some numericals regarding this. So, and some numerical I will solve regarding this hydrostatic force on some core surface, and some numericals are remaining there. So in next class I will solve some numerical regarding the hydrostatic force, and I will switch over to the next part of this buoyancy, that is called stability of the submerged and floating body. Okay. Stability of the submerged and floating body I will teach. So thank you, and share my this video so that all the students can be subscribed it, and they can get the advantage from this video. So this necessarily this is not a this is not you are not, this is just to help guys. So just to understand this one. So if any doubt, you can contact me in this mail ID. This is IIT G. This is 143 @gmail.com, and also you can contact my number. It's 8917471857, and also you can find out all this material video in this Telegram. This is Telegram. Just search civil IQ, civil IQ. So you will get the channel, and you will just add in that one all the material regarding your GATE IS. I am uploading their videos, everything will go. So thank you guys. Stay at home and be safe. Don't go outside. Thank you.